Welcome back to section 4.2. This is the second of probably 4 videos that we're going to be doing with the exponential. In this video, we're going to be talking about the exponential parent. So let's go down and take a look at what the exponential parent graph looks like. Remember that in my particular class, there's 3 things that you need to memorize about each of the parents. We had parents back in chapters 1 and 2, we keep adding more on. So this is the exponential parent. And the 3 things that you have to memorize, first of all, you have to memorize its name. So you need to know that it's the exponential function. Secondly, you need to memorize its equation. And then thirdly, you need to memorize what the graph looks like. And with that graph goes some special points. So the special points that I'd like to point out to you here, the first one is going to be this coordinate 0, 1. Now, if you think about any number a raised to the 0 power, anything raised to the 0 power is always 1. So that's why that one is there. And in this particular case, we're using the specific parent of 2 to the x power. And so the second coordinate to point out to you is when x is 1, this is going to be 2 to the first power. 2 to the first power is equal to 2. I like to call this one, you'll notice it's over here on my graph. It doesn't say 1, 2, it says 1, and then it uses a for the base. So I actually like to call this one 1, and then whatever my base is. So if my parent is 3 to the x, I would graph the coordinate 1, 3. If my parent was 9 to the x, I would graph the coordinate 1, 9. It just depends on whatever that base is. And then the third point is going to be this one right here, where you have -1 and then 1 over the base, or I like to call that the reciprocal of the base. So this one here is the reciprocal of the base, which is why my y value is 1/2. The reciprocal of 2 is 1/2. All right, now let's look at some other things that once we know those 3 things, we can easily find some of this other stuff. So my domain is going to be all real numbers. Let's look at the third bullet point before we look at the second bullet point. The x-axis is going to be a horizontal asymptote. So let's go ahead. On paper, I would expect you to draw the horizontal asymptote there. And this will help me to find my range. My range is going to be from 0 to infinity. The graph is going to pass through, I already mentioned this, the points -1 and the reciprocal of the base, 0, 1, and then the last coordinate is 1, base, 1 comma base. Now, you'll notice that for this second parent, it's actually not a different parent. But I wanted to show you this one. Notice that my base here, the first parent was 2 to the x. Now I'm looking at 1/2 to the x. So let's think about one of our rules here saying that 1/2 is a number that could be rewritten as 2 with a negative power, because negative powers cause your base to either switch from the top to the bottom or the bottom to the top. In this particular case, my 2 went to the top and my 1 went to the bottom. Now, can you look at these 2 graphs and ask yourself what kind of a transformation occurs between this parent and this one? And hopefully you'll respond with, oh, it looks like it was reflected over the y-axis. And you remember from earlier in chapters 1 and 2, a reflection over the y-axis occurs when I have a negative on the variable. And so the minute we take a look at, hey, here's our original parent, and here is this new guy, this transformation, my negative is on the variable, so it makes sense that I'm just reflecting over the y-axis. All right, let's go ahead, though, and take a look at this guy. Again, we've got these 3 coordinates. We have the coordinate 0, 1. We also have the coordinate 1 base. And then lastly, we have the coordinate -1 reciprocal of the base. My domain is still going to be all real numbers. My range is still going to be from 0 to infinity. I'm still going to have a horizontal asymptote on the x-axis, so go ahead and draw that in there. And then again, my three important points are going to be the 0, 1, the 1 base, and the -1 reciprocal of the base. Now let's practice drawing some of these. Before we practice drawing, I forgot about this little gray box here that has some characteristics. All of these are things that we have already discussed. So again, those 3 points that we're going to have, we've got 0, 1, 1 base, and then -1 reciprocal of the base. Number 2, if a is greater than 1, then my function is going to be increasing. If a is between 0 and 1, then my function is going to be decreasing. If you go back and look at these parents, here a is greater than 1, and you can see that my graph is increasing. But on this one, my a is less than 1, between 0 and 1, and my function is decreasing. I'm always going to have that horizontal asymptote on the x-axis for the parent. And then lastly, my domain will be all real numbers. My range will be from 0 to infinity on that parent. All right, so just some little tips on this one here. We've got the parent. We just drew this one, so we don't need to spend a lot of time on this one. But let's first of all graph our horizontal asymptote. And I apologize that the x-axis is so bold. And then we want to graph our important points. So we have the coordinate 0, 1. We have the coordinate 1 base, so that's going to be 1, 1/2. And then we also have the coordinate -1 reciprocal, so that's going to be -1, 2. I like to say that half of my graph looks like a parabola, and the other half of my graph is going to get closer and closer and closer to that horizontal asymptote. And you can see that that's the case as well on these guys. Half of my graph looks like half of a parabola, and the other half of my graph is getting closer and closer to that horizontal asymptote. So that's the general shape. My domain, once again, all real numbers, and my range from 0 to infinity. All right, next, for part A here, we have f of x is equal to -3 raised to the x power. Now remember that we said a is not allowed to be negative, a has to be positive. But this it still meets my requirement. This is a negative on the entire function. It's not just a negative on the 3. If it were a negative on just the 3, it would have been a -3 in parentheses raised to the x. That is not allowed. But a negative out in front of my function is totally allowed. This is going to cause me to reflect over the x-axis. And so once again, let's start out by drawing our horizontal asymptote. If you reflect that over the x-axis, it looks exactly the same. We had the coordinate 0, 1, but it's going to be reflected over the x-axis to 0, -1. We would have had the coordinate 1, 3, but we're going to reflect that, so it's 1, -3. So that shows me that the half of the graph is going to look like my half of a parabola. And then my -1 reciprocal is going to be the -1, -1/3 there. And so that's going to help me to get close to my asymptote. I do believe that I was asked for domain and range. And so we have a domain of all real numbers. And our range in this case is going to be from -infinity all the way up to 0. All right, for example part B, we're going to be moving to the right 2. So if you take your horizontal asymptote and you shift it to the right 2, it's going to look exactly the same as it did before. We had our coordinate that was at 0, 1. When we take 0, 1 and shift it to the right 2, we're going to land here at 2, 1. We would have had our coordinate 1 base. Well, 1 base would have been right here, but we're going to shift that to the right 2 units. And so it'll land right here at 3, 3. So this is going to be the half of the graph that appears like a half of a quadratic. And then we're also going to have that coordinate -1 reciprocal. So that's going to be -1/3, which would have been right here, but we're going to shift that guy to the right 2 units. And that's going to help us with getting close to our horizontal asymptote. On this one, we have a domain of all real numbers, and we have a range from 0 to infinity. All right, part C is a little bit more involved. This one, what's on the inside tells me to move to the left 2. What's on the outside tells me to move down 2. So when I move down 2, my horizontal asymptote is finally going to look a little different. Just shifting my horizontal asymptote to the left 2 won't change it, but shifting down 2 will change it. So let's remember, we had the coordinate 0, 1, but we want to take this coordinate and we're going to shift it to the left 2, and we're going to shift it down 2. And then we also would have had the coordinate 1 base, so that would have been at 1, 3. So let's shift that to the left. Oh, I don't mean to grab the 3 there. Let's try that again. Let's shift that to the left 2 and down 2. So then this is going to be the half of the graph that looks like my half of a parabola. And then last but not least, we would have also had the coordinate that was to the -1 and 1/3. And so if we take this one, let me see if I can just grab that piece and go to the left 2 and down 2, this is going to help me to get close to my horizontal asymptote. My domain here, -infinity to +infinity, and my range is going to be from -2 to +infinity. All right, so that'll be all for this particular video. Stay tuned for video number 3.